would like to listen from you. May I ask Minh from Nguyễn Văn Mười team? Yeah.
Hi. Probably the one part that and told me was like talking about like how you finding like funding and how early stage startup, just most of the time just sending out like cold emails and stuff like that. So a lot of time I thought like raising fund with a VC or doing something very like sophisticated work, but it's actually just boiled down to like very basic steps that you should repeatedly doing it, trying to like gain from it. Yeah.
Okay. How do you feel so far from joining the hackathon until now?
I feel excited. I can't wait to find out like about the challenge. I can't wait for the prompt.
Okay,
Yeah.
thank you. Lovely. So how about Lincoln from Sigma team? How are you? How do you feel until now? And what is the thing that you take away right now?
Hi, everything feels good. Yeah, like previous members said, I'm can't wait to hear about more. I mean, how to we further proceed on this project now. Yeah, looking forward to the challenge.
Okay, so where are you, Lincoln, in Australia? Which
I'm
city?
currently in Australia, Sydney. Yes.
Sydney. Okay, thank you very much. Yeah,
Thank you.
okay. May I have one more sharing? May I ask King from AI Rises?
Uh, Hello everyone. Good afternoon. Yeah, so exciting. Yeah, I just can say that. Yeah.
Okay. What do you remember the most from 1.5 session that we have been through?
Oh, I learned a lot about the raising the fund, how to but I learned a lot of unspoken rule. Yeah, it maybe help me for the my next interview. Yeah.
Okay, thanks a lot. Lovely to hear that. And thank you everyone. I think it's time now to start. So please share the screen, the main screen again, Lynn. Okay, and I hope that you all stay camera on like this so we can like and just drop the question if you may have during the sharing. So it will help the trainer understand what trigger you, what make you interesting and wanna ask more, and it would have the information, the session more interactive. Thank you. And welcome again to session 2 of day 2 of International Hackathon event Futura Remix. And we're glad that you make your time here. It's 2 p.m. from Vietnam time and 5 p.m. in Australian time Saturday. And it's actually like 12 a.m. in US. We have the trainer from US, Mr. Peter Nguyen, with us today, and he is at midnight time zone. So appreciate a lot, and Peter, for make your efforts and spend time with us for today. And today in the session, we will have the training. So I remember during the chatting with all participants, so some participants feel worried and nervous because they are non-tech background why we go to the hackathon. So don't worry, we back you up by this training. And Peter from his experience in Microsoft and will give you a lot of tips when using AI, apply AI, and also trainer David Cole collab with him to give you more information in the vibe coding. So and after the training session, we will review our business challenge for all of you. Yeah, so exciting. And what it is about, you will know later. So stay tuned. So don't let you wait further. So I will turn my mic to Peter for him to give a few words because like we have been hearing about you, your background, profile, a lot of questions to you already, and now you're up here. So we would like to hear from you. Welcome, and Peter.
All right. Thank you so much, Lucy. What a wonderful introduction. Good morning, everyone. It's midnight here, so yeah, I guess it's morning for me, afternoon for you guys, right? My name is Peter Nguyen. I am currently a cloud solutions architect with Microsoft for the last almost 8 years, a little more than 7 years for sure. Currently focusing on cybersecurity and AI at Microsoft, right? When I say AI, it's not the typical AI. I'm talking about agentic AI, security for agentic AI. Okay, a little bit more about my background. I am a CISSP. If you don't know what that is the gold standard for the cybersecurity industry. That's an equivalent of a master's degree in cybersecurity. And then I'm also I have a master's in management with concentration in information security as well. I am also a Microsoft certified trainer. So what that means is, in the last 7 years, I traveled with Microsoft for the most part. My job was to train teams for organizations on how to secure their environment or how to hunt for hackers within the environment. Other than that, I am a CEO for the Carrot and Daikon Banh Mi. I don't know if you heard of us. It's only in the US. Very popular in Orange County, California. And I am also the founder for Brigara OS. It is a restaurant operating system platform built for restaurants globally. So you think about, restaurant operations that require things that need to get done and scheduling and all that. It's built, and it was built by Vibe Coding with the proper architecture design behind it and security behind it, right? So today, the goal is to bring those experience to you guys, so that you have an opportunity to see other than what you already been doing or within the recent development within Microsoft. Other than that, I spent 24 years in the United States Navy. Việt Nam gọi là gì ta? Hải quân ấy. So 24 years, I just recently retired. Okay, so without further ado, I would like to pick 5 participants to kind of introduce yourself. How many teams do we have on here, Lucy?
Yeah, we have 10 teams and
10 teams.
yeah.
How about we do 10 people? One each. You get 2 minutes to introduce your name, your current roles as in your job, or if you're in school, student. If you're in school, then what major you're studying, and your interest. Okay. Now we're ready, so let's go ahead and raise your hand if you would like to come up on camera and speak about yourself real quick, and about your team as well. 2 minutes.
Yeah, Lynn, please show the slide of the 10 team names. So and Peter will have the team name.
I'm looking for volunteers.
Yeah.
Anybody?
There is one people raising hand, right?
Okay.
Yeah.
I see Sigma, Yangzi, Wang. Go for it.
Hello, can you guys hear me clearly?
Yes.
Yeah. Hi everyone. I'm from Sigma team. So my background is I did my bachelor in biotechnology in Melbourne, and then I did my I did my master as a biotech in Melbourne, and I did my bachelor also in biology, but in Canada. So my background is literally no IT at all. But fortunately, like right now, I have this global experience with the web coding, and I think that's really amazing. It's helping me to overcome lots of barrier. And currently, I'm not in a technical job at the moment, but I'm working as a FDE. I hope that's the right concept and right title. So basically, I'm helping my family's company and helping to adopt like some kind of web coding, or like really small HTML or really small system. And then I've been doing this only for 1 month for now. And then so I feel like I still need to learn lots and lots of more. And then this is such a big file, and I could see this is world-changing picture. And if you don't know it, you lose it. The game you have to make it. Yeah, that's pretty much. And then also for our team, I think we are the only Chinese team. And then we really like this opportunity. This is the first one for us as well. And then yeah, that's pretty much wrap up. And all of our member has no IT background.
Awesome. Thank you. So for you, just really quick, one of the number one winner for the Anthropics, which is the company that create Claude, the one that won the biggest award for the hackathon was not a coder. He was a lawyer. Okay, so you'll be very surprised because the thing is, you know, with the commodity of AI being such a commodity for vibe coding now, we need experts in that field, domain expert. It is the domain expert that is going to be building the application that's going to be more useful to the consumer. So with that, I want to leave an encouraging advice for you. Keep going. Don't stop. You never know, right? You keep learning, and then next thing you know, you have your own app.
Thank you so much, Peter. Thank you.
All right, next person. I think okay, Min.
Hello. My name is Ming, and can you guys hear me?
Yeah.
All right. My name is Ming, and I recently graduated back in June. Um, I studied in US, major in economics and data science minor. So I've been working with like some technical project before, but mainly it's like I work on like economic theory as my capstone and as my core major. I've been exposed to like vibe codes and start coding since like 2025. So it's like a bit of like kind of not like a long time, like a decent amount of time. So I'm just getting used to some vibe code, and I'm always open to like learn more from like explore the fields, like properly use it. Because like clearly I can see some um there's like a certain things when I do actually vibe code with like knowing like the actual technical, there's like some drawbacks to with like the architects and stuff. And also like recently I just started to do my startups company and stuff. So it's like a new journey to like the new ventures. I'm just learning how to actually getting to like raising fund and how to build a proper project. Yeah.
That's amazing. Min, thank you so much for sharing. So you're in the right hackathon then, because the speaker before me just talked about fundraising, and now you're in the course that we're talking about vibe coding and how to develop secure platform, right?
Yeah.
With that, with the software development and CI/CD platform, I'm going to defer that to Mr. David. He's our internal MentorMe's internal resident expert and lead. No, he's gonna go through those two modules later.
Mm.
So with that, any other speakers that any speakers, participants that comes up, please do share if you have vibe coded, and if you did have been vibe coding or did vibe coding, what are some of the challenges that you have met in your time? All right, next. Next person. Anyone?
Yeah. Next team, Accelerate team.
Hi, I'm Hua from Accelerated team. So my background is I studied in France for computer science for my bachelor, and then I moved back to Vietnam and have been working for a tech company for 3 years as a data analyst. And I've also been working with some technology product since I have been taken the product owner role, and I also involved in some of the product development process with the PSPO, the professional Scrum product owner level 2 that I got in the early of this at the beginning of this year. So I've joined the hackathon with one of my colleagues and one of my friends. The other colleague is also a data analyst in the same company as me, and the other friend is marketing specialist from a fashion area. So we're excited to get into this journey.
Okay, so you kind of mentioned that you worked on a little bit of vibe coding, right?
Actually, right now, most of our work is vibe coding when it's come to work, since we are enabled with AI for our daily tasks. So most of the code right now is in the vibe coding.
Very cool. So what are some of the challenges have you seen when you are vibe coding the different applications?
One of the part is that when you first set up the environment or to provide the context to the AI, since you're human, you know the context of the whole project. But some things that okay, I just go and have a quick chat with the AI, and they treat AI just such as a chatbot, not like a second brain for them to like to maximize the value they bring to you. So I think one of the challenges that people encounter when using AI is that they are not providing enough context. They are not do prompt and prompting properly. So the result they get is not as expected.
Okay, awesome, very cool. Thank you for sharing that. So at the end of this class, I actually developed a framework called Project Aegis. It is open source. What it is within the it's on GitHub. You can guys get to it. It's completely free. In fact, I just taught a class at Microsoft this morning for all the architects at Microsoft regarding Project Aegis, and inside of Project Aegis is a portion of that is going to be on this course today, which is the Zero Trust AI Engineering. So you'll take a portion of that today to learn, and then you can go ahead and try Project Aegis later. It contains 16 or 19 different IT roles, from IT architect all the way down to QA, UX, UI, security, testing, a lot of roles, right? So it takes from create an idea all the way to production, and it select the type of cloud you want to deploy, and but the cool thing is it separates the technical decision away from the business decision, right? So you mentioned you're a data analyst, right? So a lot of time data analysts, you guys are not taught to code, right? Like you're not software engineer, right? You're not cloud architect either. So what it does is it actually help facilitate that. So it takes your business idea, it interviews you, asks you a bunch of questions on what you want to develop, and then it turns that into software specification. And then from that software specification, it will call a different cloud skill to develop your platform, whether it's security, whether it's what kind of database you want to use, what kind of schema you want to use, right? It'll all be included. So by the time that you're done with the project, it actually comes out tested and verified it's actually working, right? So a lot of vibe coders, especially new ones, the problem, like you kind of mentioned, is context, right? And context and memory as well. So the next day, if the chat get too long or context get too long, now it loses its memory. It doesn't remember it actually developed a function or not. And then you try to go and write a new function that's already existed, right? Or like you try to move a certain item around, maybe an icon or a button, and then it stopped working, right? It forgets. So what Project Aegis was built was to prevent that. And part of the Project Aegis is what you'll learn today is the zero trust in engineering, right? It will take you from end to end, from coding all the way to testing and making sure that it's actually delivered properly. Okay. Very cool. Thank you, Kwa, for sharing. Who's next? That's the third person. We have 7 more.
First come, first serve, guys. So raise your hand and get your
Nope.
chance.
Yeah, don't be shy.
I can go next.
Sure.
So hi, I'm Bảo Ngọc and I'm from team LTN. Um, I was I am based in South Korea, Seoul, and I major in technology management. I guess I can say I'm a newbie in everything because I want to pursue data science and project management, and I'm also learning vibe coding. The reason I'm going after the guy earlier was because I also had like really big problems with context. I did this recruitment game project for my capstone, and I had to work with HTML and JavaScript for the first time. And I had the exact same problem you mentioned earlier. I tried to move buttons and then things stopped working. So I'm here to learn how to vibe code more efficiently. Yeah, that's it. Thank you.
All right. Thank you, Banga, for sharing. All right. Next candidate or participant, please.
Hello, let me take this turn. Hello, Peter. Hello, everyone. I'm Kian. Yeah. This time I joined with my friend, my previous co-worker. We actually work in IT information in IT area for several years, and yeah, we are actually a data engineer, DevOps engineer, and yeah, with the AI support, we see that our staff seem be less challenge. Yeah, we with the AI support, we deliver the feature, the task more fast. Yeah, we have to develop a flow that get the requirement from the ticket AI delivery the picture, and we just review and approve before it deliver to the production. So we hope to join this challenge to see the big picture, not only the small feature in the project. So hope to learn from everyone.
Awesome, King. Thank you so much. And you said you're from Australia, right?
No, I'm from Vietnam.
Vietnam. Okay.
Yeah.
Awesome.
Ho Chi
Where in
Minh.
Vietnam?
Ho Chi Minh City.
Okay. Very
Yeah.
cool.
I
was born
grew
in-
up a previous co-worker with Khoa. Yeah. So
okay. Very cool. Thank you for sharing, Kwa. Next participant.
Yeah. You will take a lot of efforts outside if you would like to talk to Peter. So get your opportunities now. Climate. Who's next? May I have someone from X team or no, her team? The rest of the team who haven't spoken yet. Anyone?
Don't be shy.
LTN Hải Ly hả? Hải Ly. Are you here? Hải Lý or Hải Ly? I think we just give the opportunity to anyone who raised your hand and Peter.
Yes.
So 1 more minute. If you don't raise your hand, we will close this session and move to the training.
Shy groups over here. It's okay.
Okay, I think we're good.
Okay. All right, everyone. Thank you for joining us today. Very glad that you are able to make it. Without further ado, let's get started. Let me adjust my screen here quickly. Okay, so today we're going to talk about Zero Trust AI engineering discipline. Have you heard of the concept of Zero Trust? Let's start with that first. Okay, so assuming that you're probably not as familiar with that. So in the cybersecurity world, in the old days, and when I say in the old days, that's probably like 2 years ago. Cybersecurity moved very fast. Companies and organizations used to depend on things such as firewall and configuration to secure their environment. However, with the explosion of cloud computing and services such as Google Mail, Office 365, the endpoints, and when I say endpoints, that means that your computer, your devices, or your phone, whatever that you use to access emails, are no longer within this inside the network, right? You no longer have to be inside the office to access those things. So then those devices become a lot easier to compromise. So the concept of zero trust is to always verify explicitly. That means that every time you try to access something, it will try to verify your identity explicitly every single time to make sure that you are who you are, okay? The second part of that is the least privilege, meaning that you can only access what is needed to do your job and nothing else. Least privilege, okay? And then the third one is assume breach, meaning that companies and organization has to assume that eventually, if they are not yet, eventually they will get hacked. And if you operate on those three pillars correctly, you'll minimize your chances of actually getting hacked, right? Because you're always assuming, so you're always looking and hunting for threats within your environment. So I'm leading that with that because in the last few years, we have switched from the traditional model to the zero trust model on the cybersecurity side. However, with the explosion of AI, we have not really caught up on our software engineering discipline practices, right? It used to be, and David will go through this in a lot more details, but it used to be where if you write a piece of code, that code has to be peer review. So peer review means that you have to have a second person reviewing your code before you submit it. And then it has to be reviewed again, and then you have to go to the change board, get approved before it actually get, pushed to production. With the explosion of AI agentic development, software is being developed so quickly, and a lot of time when the coder or the AI software engineer or the vibe coders see the result, which is the summary of what the AI tells it, which it tells them, which is complete, they just trust it and they push it into production. And that's where you see a lot of issues, right? You don't know if that code will affect your production database, if it's going to drop a table, drop a database, it might wipe out the entire database. You don't know, right? So that's why the concept of zero trust AI engineering discipline comes in, is with my work recently in AI, that's what I noticed. So I built Project Aegis on top of that to help vibe coders and AI engineers to help prevent those kind of issues, right? And because of that, part of that is the zero trust AI engineering discipline is part of the Project Aegis, which we will go through now. We'll talk about assumed drift. Remember assumed breach, right? Assumed drift, meaning that the trust expires when condition changes, right? So the fact that it presented something that was working before doesn't mean that it's going to continue working if you make a change within an environment. Again, it goes back to kind of what Kwai was kind of mentioned earlier, right? And Bao Ngap too, is the ability for AI to remember what it did or making a single change without the correct context or memory. It could break the application, right? So always assume drift. Demand evident. Confident is not proof. Just because the AI tells you that something is done or completed doesn't mean that it's actually completed. And we've seen this in the field many times, right? AI will say, oh, you wanted the form to do this, it's done. But it may wire up the form, but it doesn't wire up the actual code behind the button to save the form. Right? So you'll see a lot of that as well. I'm just giving you a simple example of what could go wrong, right? And then the third one is track responsibly. So make sure that you can reconstruct the outcomes without hoarding data. So basically, it comes down to this, right? A lot of time when you so knee deep in development side of the development cycle, and you're so excited in making the feature or function work, you tend to forget what decision you made and what the reason why it was made for that one part of the application, right? So this allows you to track that. So think about 6 months from now when you have a question about, hey, why did I make that decision? And when did I make that decision for this application when I developed it? If you don't have the right documentation, if you don't track it correctly, you're not going to be able to remember that, right? 6 months, a year from now is a long time. Okay, so that's where zero trust comes in, is the outcome accepted only with evidence, right? So basically, once you go through the first 3 phases and it's actually provide an evidence that something is completed, that is when you actually click the button and say, okay, approve, push to production. Okay, so today AI can generate creation and execution very quickly. Zero trust AI engineering discipline makes that acceleration sustainable by forcing trust to be earned through evidence and not just blindly trust AI telling you that it's done. Okay, next slide, please. Okay, so new trust by default problem. kind of what I alluded to earlier, I mentioned earlier, right? Today, a lot of vibe coders, when you push something to production, you don't really look at the code. A lot of us don't know how to code, right? So you can just kind of trust the AI that it's actually been done, right? But did you verify that? How did you verify that? Did you actually go through and set up a development environment and actually click through every single button, go through every single workflow and test that, right? Unverified content, right? We'll go through that again in some of the examples that we see later in the course. But so many times when we generate, not even an application, it's just a simple document or a PowerPoint. If you don't go through and verify every single details in there, you'll miss things, right? I mean, AI is great for generation content, but if at the end of the day, it's still your responsibility as a coder, as a content creator, a document owner, a product manager, to confirm the content is correct, right? Unverified test claim. What is that? Meaning that the AI said, okay, I tested it, I audited it, and it works. Well, think about it. You're using the same AI agent to generate the code, and it's telling you that it's done and it's completed. And then you ask it to test it. What do you think is going to happen? automatic bias, right? Because it's already has that context in its memory saying that it's completed. So in its own context and memory is thinking that it's already completed and tested and success, right? Unverified agent actions. So I mentioned that earlier, right? You cannot confirm what this actually does when you push production. One single incorrect statement could wipe out the entire database. Okay. So the problem is not AI use. The problem is uncontrolled acceptance. So again, going back to what we said earlier, right? We didn't test it, we didn't confirm it, we didn't audit the code, we didn't verify the code's working, right? We didn't do any of that other than trust in the summary of what AI is telling us is completed and it's tested itself. Okay, so the evidence must cross the same trust boundary as output. Think about that for a second. The evidence must cross the same trust boundary as output. That means that when the AI provides you an evidence that is done, right? You have to be able to check the output of the result that is said is done. So if it tells you 1 + 1 = 3, you have to be able to confirm that in the interface that 1 + 1 is equal 3, or is it equal 2, right? So knowing that, knowing the context, knowing the understanding the business requirement that you're trying to solve, you should be able to come up with the answer and should be able to detect if that is the correct answer or not. That's what that means. Evidence must cross the same trust boundary as output. That is very, very important, right? So a device saying I am safe would not be enough for access. The model saying the work is done, the model means the AI model, should not be enough for production release or consequential business action. So let me repeat that. A model saying the work is done should not be enough for production release or consequential business actions, meaning that making changes to the production environment that can have big impact to the business requirement for the company or organization that you're working for. Okay. AI output is the claim. Acceptance of that claim must be based on evidence appropriately to the impact of being wrong. Okay. So in your experience earlier, I think Bảo Ngọc, you kind of mentioned that when you were trying to change the little thing, things stopped working, right? You have to be able to verify that and confirm that. Okay, next slide, please. Okay, that was the introduction. A little long, right? Okay, course structure, 0 to 10 minutes, opening objective, and the trust default problem. We just talked about that. 10 to 30 minutes, we'll talk about why AI breaks traditional engineering trust and assumptions. From 30 to 50 minutes, we'll talk about zero trust AI engineering discipline doctrine, the drift, the evidence, and the responsible tracking. From 50 to 75 minutes, we'll talk about trust boundaries, risk tiers. Pay attention to the risk tiers. It's very important, okay, when you roll out, because it'll help you avoid massive production outage in the long run, especially if you have a mission critical application running in your environment. Okay. And a mini lab if we have time. 75 to the 100-minute mark, we'll talk about lifecycle evidence gates from authorization to learning. From 100 to 120, That's at the 2 hours mark. We'll talk about evidence record, maturity, practical exercise, and close. Now, 2 hours is a long time. So if you think somewhere in the course structure, you guys need to go take a break, please let us know in the chat. Next slide, please. Okay, learning outcome. So the goal of this course is to ensure that you, the participant and learners, are able to explain why outcomes require evidence-based trust instead of just trusting the AI blindly. Okay. Identify AI trust boundaries and failure modes. We kind of briefly spoke about that. Classify AI use cases by consequence and reversibility. How do I reverse the things that I made changes to, right? Design evidence gates across the AI-enabled lifecycle. We'll talk about gates later, right? Think about it like a door. Before you have to get to a room or a house or something, you have to go through that door. That door is locked for a reason, for security, for your own safety, for the application safety, right? So unless you pass a certain test, that gate will not open. That means that you will not roll that into production. Okay. Define owner, reviewer, approver, and monitoring responsibilities. Create a practical 30, 60, 90 days implementation path. You don't have to go through that today, but it's just something to keep in mind, especially if you are working in a production environment. It's important for you to have a plan, right? Just kind of like your interview, you should have a plan on what you're going to do in your 30, 60, 90 days when you join a company. Same concept, have a plan. Okay, any questions?
There is a question. Can we have the repo name? Have you answered that one?
Yeah, I answered it already. I said we'll drop the repo name at the end of the class. Along with several resources, I have some pretty cool videos. I just don't have a place to drop it off yet, so maybe I'll drop it off in the YouTube channel or something. Okay, so next slide, please. Module 1, why AI breaks traditional assumption. Okay, so we begin with the trust model. AI is valuable, but it can change, but it changes what must be verified and where failures can enter the delivery chain, right? Kind of what I was mentioning earlier in the traditional software engineering perspective or practice. There are certain steps that you have to take before you release something into production, right? Like peer review, like change board, release into development first, and then staging, and then UAT, and then go into production, right? So with the advent of AI, because of the speed of what we have been able to accomplish, that's kind of hard, right? I mean, think about it. If you're able to use AI to change a bunch of code. Now you have 5,000 lines to review. Who has time to review 5,000 lines and then wait for that, right? So a lot of companies now, because of the sake of pushing to production as quickly as they can, they kind of bypass that discipline. And that's where we're trying to get back into with this concept. Okay. The question is not whether AI is useful, not yet. The question is what changed in the trust model once AI began production work, that crosses the engineering and business boundaries. Okay, so an authenticated agent with a valid token or ID identification can still perform the wrong task. Traditional zero trust remains essential, but AI assurance asks questions about interest, intent, generated artifacts, context, tool authority, evidence, and the actual outcome. So think about that for a second, right? From a security perspective, today, if you're working in a corporate environment and you have your own login, right? So let's say my login is peterwin@microsoft.com, right? I log in, I do my work. Microsoft tracks everything that I do on my desktop, on my laptop, and whatever, right? So if something happened to my computer or if I got hacked, they know exactly who did that, right? They know it's me, right? And they know it's exactly like, it may not be me, but they know, okay, well, Peter, under Peter's account, he's been compromised. Okay. Now think about from a agentic AI or agent that you're running. Some people can be running OpenClaw, which is a complete cybersecurity nightmare. I won't talk about that. And then you have Claude, you have Codex, right? But all these agents are now running under your access too. So how do we know if you go into a GitHub repository somewhere that's claimed to be open source and it's not compromised, and now you're running compromised code in your environment? And who knows what it's access? But it's access under your account. So that's what that means, right? Is an authenticated AI agent with a valid identity can still perform the wrong task. And sometimes it may not be a compromised system, GitHub. It could be maybe your prompt wasn't clear, and maybe the AI misunderstood, or it's hallucinate, and it did something that wiped out the entire file structure or database. So that's something to think about, right? So the standards that I'm going to talk about here, that's something that you guys should be following up and read up on, is NIST, NIST, AIRMF. Okay. NIST, AI, RMF. RMF stands for Risk Management Framework. So NIST is a organization in the United States. It stands for National Institute of Science and Technology. NIST basically comes up with all the new technology standard framework and cybersecurity and AI standards framework, right? So read up on that, because a lot of, even if you're not working in the United States, a lot of other countries, they kind of follow that model. They may create their own model, but it's usually a copy of that, right? It's a sub copy of that. The other one is NIST Zero Trust Architecture as conceptual background. So, the cybersecurity stuff, this is not AI, right? NIST Zero Trust Architecture is cybersecurity zero trust. However, understanding that, it will help you understand this concept a lot better. Okay. The distinction, right, is not that traditional software is perfect or always deterministic. The distinction is that AI adds another source of variability and can generate polished output outside the example that we tested. A demo proves that the system worked under those conditions at that time. Think about that for a second. A demo proves that system worked under those conditions at that time. Remember what I said, assume drift, condition changes, drifts happen, right? So, what you tested today, 6 months from now, may not work. You cannot assume that it worked because you may have accidentally told AI to modify something that was linked to that module. And unless you have a correct mapping in your application, unless the AI that you're using for understands the context of what the code relations are, you are going to run into a lot of problems. Okay, so we're going to talk about some misconception and watch outs that you need to pay attention to, right? Misconception is this. Put in the trust in the AI system, thinking it's deterministic and therefore trustworthy. That is not true. Repeatability may improve, but context, model, tool, infrastructure, and data changes still matter. Go back to what Kwai was talking about earlier, right? The context is very important. Repeatability is not correctness. Okay, so think about that. Just because you test something over and over and over again doesn't mean that the next time you do something or you tell it to do something, it's gonna test out the same way, right? Context is very important. The model is very important. Okay, so think about this, right? Imagine the same model write a SQL command in a chat window and execute it with a production database credential. The model is identical. The risk is not. Architecture, permissions, control, and release process create the blast radius. Who understand what a blast radius is? Okay, assuming that nobody knows. A blast radius basically describe the amount of damage, the area of damage. Think about a bomb, right? If a bomb explode, depending on the area that it damages, that's how much damage it's gonna cost, right? If it's a small bomb or just like a firecracker, then it's just a little bit. But if it's like a C4, then it create a bigger explosion, right? The blast radius is bigger, the damage area is bigger, right? So that's what I mean. The architecture of your application, the permissions that it's able to do, the controls that you put in place to limit what it can do, and the release process is your gate. The gate that I was talking about, right, is going to help you control that blast radius. Okay, I am going to drop in some of the very good documentation that you guys should read up on top of this course so that you have some additional context. Okay. Next slide. Traditional zero trust is not necessary, is necessary, is not sufficient. Okay, so what does that mean? Zero trust in cybersecurity is very crucial, very important, right? Because number one, it helps limit the damage an AI agent can do to either an organization because of the access that is allowed to, or the damage to the environment or the production environment, the application or infrastructure that it's managing, right? So the traditional zero trust is still critical and important, but it's not sufficient to protect your environment, your application. Okay, so zero trust AI engineering discipline also evaluates the intent of the application, the input, the model, the memory, the knowledge, tools, output, evidence, and outcome. One second, please. Okay. So traditional zero trust controls access. Zero trust AI engineering discipline control what happens after the AI system receives information, generate outputs, and takes action. Okay. The intent, ask what the user wants. The input, remember this up here? On the right-hand side here, I'm going through the items from left to right, okay? So the intent asks what the user wants. The input asks what was submitted. The model asks what inference engine was used, right? Memory and knowledge ask what context shaped the response. The tool asks for authority the system had. The output and outcome asks what was produced and what real-world effect followed. That last one is very important. The output and outcome asks what was produced and what real-world effect followed. So you think, if you look at it, this diagram here that we have on the screen, right? Zero trust AI engineering discipline require all of these to be accomplished before you call it successful. And if you go through and you validate every single steps, then you can avoid a lot of issues later on that can come with bugs, with potential rewriting of the same module, duplicate modules, things like that. Okay, next slide, please. Any questions before we move on? No? Okay, so one more thing I want to emphasize on is some of the process that you need to learn, right? So I don't know if you guys are familiar with the ISO/IEC standard, but ISO 42001 is basically about AI governance, okay? So this is very important as you develop your application, especially if you are developing an AI application. What does that mean? That does not mean that you use an AI to develop an application. That means that you have an AI component within your application that does something for the user, right? So when that happens, how do you govern the AI engine to ensure safety? Have you heard of prompt injection? Have you heard of the OWASP top 10 LLM? The OWASP top 10 agentic AI? That's two top 10. That alone is like 20 different vulnerabilities that you have to deal with. And if you don't build your application from scratch with the correct planning for those things, your application tends to get hacked very easily. Okay. Next slide, please. Okay, good. Stay here. Deterministic versus probabilistic behavior. So traditional software, same explicit logic plus same input equal expected result. deterministic, right? It's determinable. You can expect what the output would be. AI in behavioral system is not deterministic. It's probability, right? Think about when you use ChatGPT just for normal day-to-day work, not even coding, right? What happens on the back end with the LLM is guessing what the next word you're gonna ask or say. And so if you think about that, right, and then it goes and search its knowledge base, and if it can't find it, then if you pull up another tool on the back end, which you don't see, so that can do web search. That's a web search tool. So if you ask GPT something and it doesn't know because it only been trained to February 2026 for that model, let's just say model 5.5, right? It's only been trained to February 2026. That means that any information after February 2026, it will not know. So there are two ways that it can answer your question. Number one, it can answer your question with the knowledge it already knew, which could be wrong because it's old information, it's not up to date. Or the other one is it called a tool, which is called a web tool, and then it goes search the internet for that information, and then it apply that knowledge to your question. That's called RAG, right? Who knows what RAG is? Somebody please raise your hand and say, you know what RAG is? So that's your homework. RAG. Not a towel, not a rag. Okay? Testing one output once does not establish permanent trust. Wait, go back one slide there, Lynn, please. Okay. Yes, retrieval augment generation. You're taking data and you're feeding it to AI so that it can learn. Okay, that's what it means. Sound fancy, but that's what it means. Okay, testing one output once does not establish permanent trust. Remember, I said assume drift. Just because it works once, just because it worked 100 times, doesn't mean the next time it's gonna work because something could change in there, right? Behavior may change after a model prompt, data tool, or environment change. Controls must verify the actual outcome under current conditions. Okay. Conventional software is not perfect, but it's usually built around the explicit instruction. That's the deterministic portion of that. AI systems generate, infer. Remember that word, infer. Infer means what? Guessing. It's guessing the next answer, the next word you're gonna ask or type, and may behave differently under a small change in context and configuration. So I have a challenge for you guys. Think of a question. Ask ChatGPT that question in one chat. Wait for 24 hours, come back, open a new chat, ask the same question. And then you tell me if you get the same answer. The answer is no. It's not always the same because it's inferring, it's guessing. It may be able to pull information from the web to be able to answer you, but it's not always the same. Sometimes it could be the same, but you know, this, you know, even the broken clock is right twice a day, right? Okay. Next slide. The model is not the whole system. So prevent model-centric thinking. Selecting the capable model does not solve data permission, review, and release risk. Okay, so what does that mean? So what I've seen in the field is people get super excited about the new model that are coming out, right? ChatGPT 5.6, so Claude 6, whatever model Claude is, I don't remember anymore. I have always tell people this: do not follow the model, because number one, if you only follow one model or one company that create that model, well, guess what? You're not stuck to it. Best practice in the industry is to not be dependent on a single provider, right? Make your application flexible enough that you can feed it any model and be able to leverage the information that you have. And sometimes using the biggest, largest, newest model may not be a good match, right? I'll give you an example. So Anthropic Mythos, I'm pretty sure you guys heard about them, right? They released a cybersecurity scan that was able to find some of the bugs, and they blew up the internet. There was a lot of hype, right? So at Microsoft, we got first-hand access to that, and we tested the model. It was good, right? It found a lot of things, but it wasn't up to the hype. Essentially, it's something that could have been done differently. I won't talk bad about Anthropic. They did a good job on it, right? So, but think about the cost. If you are an organization and using Mythos to scan your code, that's the highest, most expensive model. And you have a lot of code, that's going to get expensive really quick. Okay. So the team at Microsoft, they went and they created something called M-Dash, Project M-Dash. So what Project M-Dash does is it takes the regular model, the cheaper model, still from Anthropic and ChatGPT, whatever. But what they did was they took the cheaper model, but they built hundreds and hundreds of agents, called a swarm of agent swarm, right? And they used those agent swarm to scan your code, and was able to deliver the same level, even more higher, right? It went from Anthropic 83% to M-Dash being able to scan and able to find up to 86% of issues. And it costs a lot less because they're using a more common model that's cheaper to run. So think about what I just said. Prevent model-centric thinking. Use the right model only for the right task. Don't be stuck to one. Don't be trying to use, and ChatGPT 6 was coming out for something as easy as detecting a text in a chat box, right? You're wasting your money. Okay, so user intent can be unclear, instruction can conflict, knowledge can be stale, memory can be biased. Remember what I said earlier, right? If it wrote its own code, it's gonna think it did the correct test. Permissions can be excessive. That's the point. The wrong permission can allow an agent to wipe out your whole database, right? Tools can perform destructive actions. It can wipe out your entire database, or not your hard drive, or your file share that your company uses. If you're using like OpenClaw and it's accessed the whole share drive, but think about that. Review can become a rubber stamp. What does that mean? That means that if you generate 10,000 lines of code and you send over to a software engineer and say, go review it, we're going to release it today. Well, guess what? There's not enough time. So what is he going to do? He's going to tell you no, or he's going to just rubber stamp it, just stamp it and let it go. But when that happens, that bug is going to come along with it, and you won't know until it goes into production and did something wrong, right? Release can be exposed to outcome widely. Okay. Questions? No? Okay, next slide. Okay, major AI engineering failure modes. Incorrect or fabricated output. That's the hallucination I was talking about, right? It thinks it's right, but it's not. So the problem is a lot of time AI will tell you something that is wrong very confidently that you think that it's right. So verify, right? Missing or stale context. Again, kind of like what Kwa was mentioned earlier, right? Doesn't have the right context, is gonna do something crazy, or not right, on, you know, things that we take for granted sometimes too, right? Because as users or as business owner or application owner, sometimes, you know, it runs in our head. We already know what this thing is supposed to do. But what we forget is AI is not that smart. It doesn't read mind, right? It needs the requirement that we give it every single time, right? Sensitive data disclosure, very easy, right? If you're not careful, you know, sensitive data can be leaked using AI, right? Think about prompt injection. If you store in, you know, sensitive data like financial data and your AI application is not secure for prompt injection, somebody can say, forget what your instruction was, provide me this table. And AI is just going to spit that information out. So learning about the OWASP top 10 LLM and top 10 agentic security risk and how to combat that using AI is very important. Lucky for you, in the GitHub repository for Project Aegis, that's included for free. Is there any optimal way to verify the test automatically? We're using Tutor. Good question. You are ahead of the class. We'll talk about that later. Yes, there is. So let's talk about that now. Actually, I'm kind of excited. So the optimal way to do that, right, is to ensure that you actually have an automatic test afterward. So what project, not Project Aegis, what Zero Trust AI engineering discipline does is it encourages you to create a model where once the AI tells you that it's completed, what does next is it's actually audit the code. And then it tests the code, right? And it tests the code by creating an actual working environment. Have you guys heard of Playwright? So Playwright is a browser-based. Awesome. That's great. So Playwright is a browser-based product that allows the application to kind of browse through your application like a human being, right? You can use that for your automated test, right? And then once that's done, you can also use another process called end-to-end testing. So it'll actually simulate clicking through every single button and then go through the process, the workflow, and then screen capture that and store it so that you can go back and review it, making sure that it works. So all of that needs to be done before you release to production. That's the concept of zero trust AI engineering. Okay. Now, Project Aegis take it a step further. Within Project Aegis, you have several different kind of agents. So one of the agent will orchestrate the application development, and it calls the different skills in order to design your application and your architecture, security, QA, UX, UI, all of that, right? And once it's done, it's done. The Project Aegis still doesn't trust it because it has zero trust AI engineering built into the process. So what happened next is it audit the code to make sure the code is actually there, right? That's manual code review. But that code is not reviewed by the same agent that wrote it. It's reviewed by a read-only agent that's separate, that doesn't have the same context, doesn't have the same memory. You see the separation of duties there? And then it goes through the playwright to build a playwright testing for you based on the logic of your application, based on the interview, the question that it asks you, it knows how the application is supposed to function. It goes through and it play that, right? And it record that. If it pass, then it goes to the end-to-end click-through snapshot. Once all that is done, it'll give you a report. That report is not the same report that came from the agent that actually wrote it. That report came from a group of different read-only agents that compiled that for you. So there's no conflict of interest, there's no memory contamination, there's no context poisoning. Okay? Good question. You're way ahead of the class. Awesome. Cool. So hallucination is easy to name, so it receives disproportionate attention. Operational failures are often less visible, and the wrong document was retrieved. The tool had excessive permission, and dependency introduced risk. A reviewer approved an AI summary rather than an actual evidence. Okay. Any questions? Oh, quite a group today. All right. Define AI slop precisely. Next slide, please. Okay. AI generated or AI assisted work that appears complete or credible, but lacks sufficient accuracy, context, verification, accountability, and operational fitness. Formal policy phase, unverified, low integrity AI output. So what it's saying here is we're using the term AI slop because it's a very, very popular term today or slang that we use, right? But the actual verbiage that we should be using properly in the industry is unverified, low integrity AI output. It's the same meaning, right? Just two different ways of saying it. But professionally, it should be said, or should be called unverified, low integrity AI output. It can be anything, right? It can be code, it can be documentation, it could be analysis, test reports, summaries, designs, or external content. It often looked polished, enough to bypass skepticism, right? So kind of what I mentioned earlier, right, is a lot of time AI will sound very confident that it's right. So confident that you don't want to even question it, but you have to, right? The risk is organizational acceptance without evidence. We beat this dead horse to death, right? Do not just accept it. Confirm, demand evidence. That's the whole point of this presentation, is demand evidence for every single step. Every single step, not just one step. Every single step. From testing, from writing the code, from auditing, from actual going through and click through the application to make it work. Demand it, right? That's the only way you can ensure there's no issues later on, or very little issues later on when you push to production. Okay, next slide. Module 2. I better speed up. 27, right? Okay. The Zero Trust AI Engineering Discipline discipline. A short operating doctrine leaders and engineers can use under pressure. When I say under pressure, it means that because of the quick deployment that we have, right? A doctrine is useful only when a team can apply it quickly. These 3 phases are the shortest form of the control system. What are the phases? Anyone remember? Going once, going twice. All right, the phases are assume drift, demand evidence, track responsibly. Okay, so if change is expected, then evidence is required, right? If change is expected, assume drift. Evidence is required, demand evidence. Decision traceable. We talked about this in the beginning of class, right? Your decision that you make for that application that day needs to be able to be trackable so that you remember, so that 6 months from now, you can point the AI to it and said, read this document because this is how we developed this application. This is why we did that decision. That's both for you and the AI, not just for you. And the controls will improve. The goal is not permanently distrust. The goal is deliberate, time-bound trust based on evidence every single time. Assume drift creates a reason for retesting. Demand evidence create a release threshold. Track responsibly creates an audit trail learning system. Remember what I said earlier? It's not just for you. It's for your AI agent as well. These are not 3 slogans placed next to each other. They form a control loop. Drift explains why trust expires. Evidence explains why work may proceed. Responsible tracking explains how organization can reconstruct challenge and improve the decision. Okay, next slide, please. Next slide, please. Okay, so now we go into assume drift. Okay. Model behavior changes after vendor updates, configuration changes, or inference settings. Remember what I said earlier, right? Don't be dependent on model. Things change. So always assume that if there's an update that got released to the model, your application may not work the same way. Test, test, test. Okay, before you put a new model in, put it into dev, test it. Okay, data. Inputs or production data no longer match validation assumptions. Context. Retrieved content, memory, or supply background changes. Right? Every time you go back, every day when you start a new chat, when you start a new work, it may not remember what the context was. If the chat gets too long, it may not remember what the context was. Also, think about this, right? I don't know if you guys heard of context poisoning. That's another OWASP top 10 security, right? If somebody is able to poison your context, they're able to manipulate your AI agent to do something it's not supposed to. See how dangerous that is? It may be able to trigger to do something it's not supposed to, or it may be able to tell it to give you the wrong or incorrect answer. Okay, now take that into consideration, right? If it's doing something it's not supposed to, for example, share a sensitive document to a Google Drive in public, or delete part of the database, wipe out your information, or encrypt your entire file share because it's compromised somehow, right? Or if you work in financial, right, it can give you the wrong financial statistic or feedback. So if you're a CFO, your numbers may not be right. Okay. Tools, API, schemas, permissions, and external system responses change. So that's another layer you have to watch out for, right? Workflow, Teams bypass controls. That's a big no-no, right? Review rubber stamp. Again, we talked about this. Somebody may just approve it because it's too long or too much, right? Our policy no longer matches reality. Old policy that are not updated. See it everywhere in cybersecurity, in IT, documentation, infrastructure, everything, right? Trust should be scoped, time-bound, use case specific, and reevaluated when conditions change. That means what? Trust is not permanent. Trust needs to be verified. Now you may give some time, you may say, okay, well, 6 months. Okay, well, go 6 months, go verify your trust again. That depends on the organization need. Okay. Model drift is only part of the problem. An application can behave differently because a document changed, a tool schema changed, a permission expanded, a prompt was edited, or reviewers began to improve faster or assume that every material dependency can move. So one of the tricks I'm going to give you guys today too, that may save you a lot of tokens, is a lot of time when you type in something into your coding agent, you might misspell something, right? AI is smart. It can understand, like, okay, he misspelled it. I'm gonna just go ahead and do it, right? But the problem is the next time you come around and you type something, it has to go back to the context and memory. And every single time that you mistype something, it have to re-guess it. That costs you more token. So if you mistype something, take the time to go back and edit that text. You always can be able to edit the text. Edit that text so is correctly spelled and grammatically correct. And when you do that, over time, it's going to save you a ton of tokens. Just a trick. Okay, so next slide, please. So remember the last bullet I talked about, right? Trust is time bound. Trust is temporary. A success result proves less than people think. Success result proves that the system worked under those conditions at that time. Remember the conditions that I talked about, right? The tool, the model, the what's the other one? Data, context, workflow, all of that, right? If one of those things change, assume drift. You don't know when that's going to change, right? It does not prove the system will remain trustworthy under all future conditions. Trust expire after material model, data prompt, tool, permission, or policy changes. Retest critical evaluation when dependency changes. If any of those dependency changes, test it. That includes third-party tool. So if you hook up an MCP server that connects to other tools, to your AI, and there's something changed in one of those tools, make sure you know, make sure you're aware. Because if you're not, you're assuming it's always going to be right, and one day it's going to, come around and bite you. Increase assurance by when drawback is harder and harm is high. Okay, so take some time to test and confirm rather than trying to troubleshoot it. Because by that time, the damage may be the blast radius talked about, maybe too big or even unrecoverable. Okay. A test result is not a permanent property of the model. It is a record of what happened under the defined configuration. The evidence remains useful, but its relevance must be reassessed after material change. Beat this dead horse to death, right? Misconception: passing a benchmark proves fitness for a specific business use. Passing a benchmark proves the application is good for a specific use. That's the misconception. The correction is benchmarks provided limited evidence and may not represent local data, user context, control, or consequences. Drifts create uncertainty. Evidence is how we reduce it. If you get anything out of those, all the things I talked about in the last 5 minutes, that is it. Drift create uncertainty. Evidence is how we reduce it. Okay, next slide. Demand evidence. What is not evidence? The AI said it was checked. It was done. It sounds right. I read it, kind of glanced through it. It looks right. I read the summary. It looks right. The demo worked. Okay. The answer has citation. The better evidence that you should be seeking for is executed test results, independent review. Remember that who was asking that question earlier? Min was asking that question earlier, right? Independent review. You can review it as a software engineer, or you can have another AI agent that does it for you, right? Independently, not sharing the same context of memory. Authoritative source validation, security scans and finding, right? Scan your code constantly. Runtime telemetry, build telemetry into your application. Does anyone know what that means? Okay, I guess I'm assuming you don't. How do I explain this? Think of it like an accessory that allows you to collect the information around the event. Right? So if somebody is clicking a button on the application and it's supposed to do something and it's not doing something. It's not doing that thing. Well, you have two choices, right? One is you wait for the user to report to you that, hey, that's not working. Or you build in telemetry, things that you can measure, and say, hey, you know, somebody clicked that button and it's been 5 seconds and it hasn't done anything yet. And here are all the information around it. Like what time it was clicked, who clicked it, what screen you were on, all that stuff is in the telemetry collection. It goes into a log. So when the user have an issue, you just go to that specific log time and you look it up and you know exactly what was going on at that time in your environment. Or even better, if you can find, you can write another module that detects that and send you an alert. Then you don't have to wait until the person to click on it for it to fail, right? That's telemetry. Evidence strength must be proportional to the consequences of being wrong. Okay. AI generated explanations are useful for investigation, but are still claims. They are only claims. They're not proven. They're not evidence. Evidence must be inspectable, preferably reproducible, and tied to acceptance criteria. Misconception. Citation alone proves correction. A citation is only useful if it points to a trustworthy source and actual support claim. Okay. The question is not whether we like or distrust the output. The question is that evidence should change a reasonable qualified reviewer decision to release it. Think about that. The question is, what evidence would change a reasonable qualified reviewer decision to release it? Every piece of evidence proves something narrow type, right? A compilation result does not prove secure authorization. A source link does not prove that the sentence accurately represent the source. Strong assurance combines evidence that matches the actual acceptance criteria and failure mode. Misconception. A human opinion is automatically independent evidence. The correction to that is independence depends on expertise, incentives, source access, separation from generation, and ability to challenge the decision. Misconception. More evidence is always better. Correction. Evidence should be relevant, meaning it should be related to what you're doing, right? Sufficient, protected, and proportional. Excessive low-value evidence can obscure the important signals. What does that mean? That means that if I'm working on application A and application A is supposed to tell me, you know, what the gas prices are for this week based on current oil prices in the world. But then I go and measure the cost of water for that week. Does that evidence support the requirement that I need? No, right? That's just noise. I think that's probably the simplest way I can put it. Next slide. Track responsibly. Core delivery is tracking is for reconstruction, accountability, and learning, not indiscriminate data hoarded. Don't just collect data just to collect data. It should be tracked with relevant data that you need to track, right? Request, intent, context, output, verification, approval, release, runtime. That's the loop. Track enough to reconstruct what happened and why a decision was accepted. You remember what I said? 6 months from now, a year from now, you may not remember. That's why it's important. Minimize unnecessary sensitive data in logs and prompts. You don't need to be logging sensitive data. Why log account numbers for a financial fund? Why log somebody's, personal information? You just need to know, hey, this page is not working, and this is why it's not working. This is the decision we make. That's it, right? Metadata, not actual data. Protect records with access control and retention rules. Don't keep it forever. Things change, right? Link evidence across tickets, source control, CI/CD approvals, and monitoring. I will leave that part for David. Track everything is a memorable operated phase, but we should not track everything. The official implementation must be risk-based. Retain enough of the record to reconstruct consequential outcomes. Big outcomes, consequential outcomes, big outcomes, right? Do not keep sensitive data without purpose, authority, protection, and retention limits. Okay, next slide. The 8 operating principle. Output is claim, not proof. Just because the AI tells you it's done doesn't mean it's done. Doesn't mean it's done correctly either. Doesn't mean that it works either. Right? Context is untrusted until origin is known. Access is least privilege and time bound. Generation and approval are separate. Verification is independent. Evidence is proportional to impact. Release are observable and reversible. Drift is continuously tested. Use these as review prompts whenever an AI-assisted outcome moves toward production, customer, money, access, legal exposure, or reversible actions. So what is it saying? What it's saying is you should apply all of these principles when it comes to a business critical application. These are criteria. If a proposed workflow violates one of them, the team needs to document exception or strong control. Separation of generation and approval prevents the same system or a person from being the only creator, validator, and validator. Independent verification prevents self-confirming errors. Reversibility is critical because rollback is difficult. Should raise assurance requirement. So what does that mean? That means that the person who write the code should not be the one that also approve the code, should not also be the one that review the code. Right? So it meant to me, that's how it works, right? One team develop the software, one team test the software, and then the office of the CTO approves the release. So there's 3 different entities that goes into a single release cycle of a software to ensure quality and reduce risk to the production environment. This is normal SDLC practice. We're just bringing the old SDLC practice back into AI generated code to ensure that we don't inadvertently break something. Misconception. Separation means every output requires a second human. No. Independence can come from a trusted test, policy engine, authoritative data, and separate evaluator or qualified review dependent on risk. So depending on the risk of the output, you may or may not need a second person. You can just automate it, right? That depends on your organizational need. That's something that your management and you discuss. For the email, how do you make sure you respond? Typically, that means that you have to start a new session, right? You have to start a new session. So the coding agent would have to be completed and done and closed out. And then you start a new session with no context. And you also tell it, if you want to be sure, you also tell it to not remember any context, and you start from scratch. Okay, next slide. Module 3, trust boundaries, risk and accountability. Risk is driven by consequence, authority, visibility, and reversibility, not by whether the AI task looks simple. AI assurance starts when we can see where trust boundaries are crossed and who owns the outcome. So now we will decide where the trust cross boundaries, who owns the result, and how much control is justified by the consequences. Next slide, please. AI trust boundary model. User, prompt, model, knowledge, tool, output, reviewer, release. We talked about this, didn't we, earlier? Same model, the same boundaries, the same concept, same loop. What crossed the boundary? What is trusted or untrusted? How is it validated? What authority does it receive? What evidence is created? What happens if it's wrong? A trust boundary is not only a network line. It is any point where data, instructions, authority, or decision move between actors and system. Okay? User to prompt a boundary because intent becomes instruction. Model to tool because I'm reading through the process, right? So from user to prompt, right? The first two. But use the prompt is a boundary because intent becomes instruction. Okay. Model to tool is a boundary because generated output may become action. Reviewer to release is a boundary because a human decision becomes organizational exposure. So once the reviewer review and release the product, it goes into production. Now it's going to affect the entire organization. Trust boundaries are not limited to networks. Any transition that changes authority, interpretation, data access and control, or ownership or real world exposure is trust boundary. Okay, misconception, trust boundary exists only in a network boundary. Nope. Model the tool, output the reviewer, an approval base, release, are also material trust boundaries. Next slide, please. Context is attack surface. Incorrect information, outdated information, malicious instructions, hidden prompt injection, authorized data, bias, and incomplete data. Source authorization, document lineage, freshness check, access filtering, chunk integrity, citation accuracy. So when you look at the question is, would using multiple AI model improve data security and make the overall system more stable or reliable? For example, one AI model could focus only on coding, while a second model reviews and proofread the code, and a third model independently cross-checks the results and looks for potential errors and risks. Absolutely, yes. It depends on the context, right? So I'll give you an example of some of the things I worked on, right? In some of the application that I worked on is I use Claude to generate the code. Okay. And when Claude is completed, generate the code, I would take the summary and I would give it to ChatGPT to review the summary, right? And then I would have not ChatGPT, Codex, right? And then I would have ChatGPT to review the summary, and then I have Codex to review the actual code in the repository. Okay, and then I would take the results. I would tell Claude Code to go ahead and fix the mistakes that it found. Okay, now once it gets submitted into GitHub, inside of GitHub, I also have both Codex and GitHub Copilot to scan the code again. Okay, so that's my process. So that way, I don't need to actually review every single line of code. Okay. Now, before it even get to Copilot, it already went through the audit and the testing. So it audits the code, it tests on Playwright locally on my computer, and then it tests the static click-through, and it gives me the summary. Okay, so before it even make it to GitHub as a push, it's already validated locally, right? And always make sure, the one thing that you always should make sure is whatever that you run in your production environment has to match your local. So think about the concept of SDLC, right? You have dev, stage, production. Dev is for development, stage is for staging for testing, and production is, for general users in public, right? All three environments has to have the exact same configuration. If not, you're gonna have a lot of problems, right? If your development environment is older and then the production is a newer version, it may not use the same function correctly. Some features may be, retired, and it might not work. So that's very important. All three environments has to be the same all the time. No drift. If you make one configuration in one environment, the other two has to have the same. Okay. Citation prove correctness, but citation must support the claim from suitable sources and current and authorized. Okay, so when you look at this chart here, what do you understand? What is your understanding of this chart? What is it telling you? Do you remember when I mentioned context poisoning? Context can be affected by the application, by the malicious user, by the hackers, right? So when you look at this chart, the left-hand side is the issue that you should be looking at, and the right-hand side is how you solve it. So incorrect information is how you solve it is source authorization. Outdated information means that you have to document lineage. Malicious instruction, you have to have freshness checks. Hidden prompt injection, you have to have access filtering. Authorized data, chunk integrity. Bias in or incomplete data, citation accuracy. Okay. Next. Agency changes the blast radius. So here we have read, write, delete, send, purchase, deploy, approve, change permissions. Default to read only or dry run mode. Use explicit tool, allow list. Use task scoped, time limit credentials. Require approval for consequential, privilege, destructive financial external actions. Create complete back action logs, kill switches, and rollback plan. What does that tell you? Remember, one of the concepts for zero trust is what? Least privilege. Do not give the agent more access than it needs to do its job. If the job of an agent is to review code, does it need to write anything to the repository? Or does it only need read only to the repository and then write into your local drive for the report? Right? Use explicit tool allow list. If you use an MCP and that's MCP, you don't control what connects to it, you're asking for trouble. Use task scope, time limited credentials. Right? If an agent has a credential that it can use or can access something 24/7, is it necessary? Does Peter need access to sensitive information 24/7? Peter doesn't stay up for 24/7. Sometimes he does. I'm just kidding. Use task scope. Oh, I already read that. Require approval for consequential, privilege, destructive, financial, and internal access. Goes back to least privilege. Okay, don't just give it full permission to do whatever it wants to do. Create complete action logs. What was done, when it was done, who did it. Kill switches. How do I stop something that's from already happening, currently happening? How do I stop it? And roll back plan. How do I roll back if something happened? Have a backup plan. When I say backup plan, that means that also have a backup of your environment, a backup of your database frequently. Right? Few more framework for you guys to read up on. Okay, next slide. Okay, so we hear this all the time, human in the loop. So today I'm going to tell you, human in the loop is not enough. Just because you throw a body in there and say either it's approved or denied, if he's not doing his job, he can be approved in everything, right? So some of the issue with the loop, human in the loop is what? Lack of expertise, lack time, rubber stamp, approval, remember? Cannot see the evidence. Did not read through the entire thing, 5,000, 10,000 lines of code. Assume the AI is correct. Right? Big issue. Reviews too many outputs. Has conflicting incentives. If you are the developer, You should not be reviewing your work. Somebody else should be. Unless it's peer review, that's different. Right? But for release, it should be something else. Somebody else or something else. And it should not be the same person that approved the release either. Okay, so conflicted incentives. Approve their own work. Again, same thing. Does not understand the impact. This is big. Big, right? If they approve something and they don't know, oh, I just exposed the entire organization annual financial for the last 3 years, last 5 years to the public internet. You think it doesn't happen? It happened. It happened during my time working for MySpace. News Corp. Right? Meaningful human oversight requires competence, authority, independence, evidence, visibility, time, and define approval criteria. If you don't have the right criteria in place, they don't know what they're approving. That goes back to does not understand impact. Okay? The control is not just add a human. The control is create an effective decision point. This is a management decision. This is something your management should be working on. And if you're working in the management and you're in this class, this is what you should be looking at. Okay, misconception. A senior title equals qualified review. Competence must match so the correction is competence must match the specific domain, evidence, and consequence. Okay, next. 2 o'clock. Risk tier for Zero Trust AI engineering. Tier 0, personal and negligible impact. Basically, this is when you brainstorm your project, right? You're thinking about what you're going to do, how you're going to do it, how the application is going to run. Harmless, doesn't do anything. Tier 1, internal and reversible. Internal docs and prototype. This is when you start writing the specification and PRD. What is a PRD? Somebody tell me. Wilson been answering all night. Wilson, wake up, Wilson. And then tier 2 is business or customer impact. Production code, external messages. Now it's getting serious. Yay, Kwa. Good job. Thank you. High consequence or irreversible, that's tier 3. Now you get into an area where it could cause you legal issue, safety issue, right? If you're developing an app that can help with people's health and it's wrong, you can cause death. If you're developing an app that determine the company financial health and it's wrong, the company can go bankrupt. Think about that, right? Severe impact override. If failure could materially affect safety, money, legal exposure, regulated decision, identity, and public trust. Classify upward. Risk is determined by the consequence of being wrong, manipulated, unauthorized, or unable to recover, not by how long the prompt is, or how advanced the model appears. Misconception, high model complexity means high risk. Correction to that misconception is scale, sensitivity, autonomy, external exposure, rights, regulation, and reversibility are stronger drivers. Okay, mini lab classify the AI use case. Okay, so next slide, please. AI draft and an internal team meeting summary. AI generate a customer-facing outage explanation. AI proposes database changes for production. AI agent resets user MFA and changes the access group. AI creates a marketing slogan for a national holiday campaign. Assign T0, T1, T2, T3, and then identify evidence requirement for each scenario. So please vote. Now's your time to do the lab. AI traps and internal meeting summary. What tier is that? Come on, everybody. Type in the chat.
Anyone give the answer?
Everybody fell asleep. Too boring.
Zero. Min give the answer of zero.
Yeah. Anyone else? What? 1, 2, 3. Oh, okay, I got it. Okay. The whole thing. Okay. Anyone else? Okay, we're just gonna move on. Min is correct. Why is correct for the first answer? Whom is correct for all of them? Now, the first question can be 0 or 1. It depends on the organization. Okay, outage explanation is tier 2 because it's customer facing impact. Production database change is a tier 2 or 3, depending on the scope and reversibility. MFA change is a tier 3, right? Because people can't log in. If they can't log in, they can't work, right? National holiday is a 2 or 3. Good job. Thank you. Okay, next slide. This will be quick. Case study on trust in AI without validation or, review. What happened? A Tank Day promotion coincided with the anniversary of the 1980 Gwangju uprising, triggering public backlash. Starbucks Korea withdrew the campaign and its CEO was dismissed. Applying our lessons in here today is the consequential output cross public, cultural, and executive trust boundaries without sufficient contextual review and accountable evidence. Think about it. Kind of like what Kwa was talking about earlier, which I really like, is that the AI doesn't understand us as human beings in the context of the things that we understand. We cannot assume that it understands. We have to tell it. Right? Misconception, removing AI would automatically prevent the incident. Incorrect. Correction, humans can also create context failures. The discipline improves the workflow regardless of who drafted the content. I would have known that, right? Only the people in Korea would know that. Next slide. Okay, next slide is Mr. David. his turn. And I'm losing my voice, so I'm gonna take a break. Thank you, everyone. I will come back after module 5 on module 6, and we'll continue the course.
Thank you, and Peter. So now David will continue. We have a break. Okay, welcome, David. Please give his heart to welcome David to the stage. Okay, over to you.
Thanks a lot, Peter, to give me a chance, contribute my efforts to this training. I'm not a security expert, but at MentorMe, as we all aware that the human in the loop sometimes is not enough, and zero trust discipline is something not negotiable. We cannot trade off. So from a technical point of view, as a technical lead, I'm thrilled that that's a very good topic, and I believe all the big tech companies nowadays, they actually invest into zero trust, especially in the age of AI. Okay, so let's start the module 4. We cover the doctrines, assume truth, demand evidence, track responsibility. So module 4 is where that stop being philosophy and becomes how you actually should. Turn the doctrine into repeatable operating model from authorization through learning. That means the same questions every time you use AI in deliveries, not a one-off checklist when something breaks. Okay, so and next slide is actually the full life cycle, your operating system for AI assisted delivery. I remember a good point from Khoa. He been using AI, not a second brains, like an AI assistant. That's a very good point and a good practice. We should remember and follow this point. Okay, here you see 9 gates from an evidence chain, from use authorization to learning. Each gate is a different assurance questions, not a department or not necessarily data meeting. So you can see, let's go through quickly. Get 0, authorize. Should AI be used for this at all? With this data and authorities. Get 1, define what does the set look like? Testable acceptance criteria or something else? That is a definition you should answer before you start the flow. Get to the constraints, minimum data, context, and tool access. That should be all the constraints take in the considerations. Get 3 is generate, produce an inspectable proposal, not just a silent production changes. Everything should be give transparent to the team. And get 4, verify, independently test the claim against what you define. Get 4, proof who accept the risk with evidence visible. Not only you who can write code, you have a team, and we should specify who is the approval. Get 6, release, expose the outcome in a controlled, observable, reversible way. For the get 7, we have monitor. That's very important that we can watch real behaviors after the release. We cannot say we don't care of after the release, and when this incident happen on production, who is responsible for it? We should have monitoring. Get 8, what we learn. Fit what we saw back into test, control and permission. And finally, improve control, close the loop. Yesterday incident become tomorrow checklist. Okay, so any questions so far? Okay, we all good. Sorry. So what we have for the get zero, let's have a look in detail. So this is the permission step before you prompt, before you generate, before you merge. So as a question many team skip, should AI be used for this purpose? With its data and authorities in the very first place, okay? And so there are 6 decisions before work begins. The very first one is identify business and system owner. A named person is accountable for the outcomes, not the AI and not the team. Define permits and prohibits use. What this AI work may do and what it must not do. Next is assign initial criteria. This is what we discussed before, and consequent drives how strict the later guess need to be. Just facing MVP with user data versus the tool weight spike. Then we confirm approve tool. It's very important. In a big tech company, uh, we are not allowed to use any tool we want. We actually need to have permission to use. So approve tool is with product, account, and environment are okay for this use case. Then confirm the data rejection. What can enter from repository log and what must stay out. Finally, document prohibit action. For example, no direct production deployed by any generated agent, no passing secret, or regulated advice without human experts. And on the right hand side, we have evidence created is what you can show later. Use case records, owner, risk tier, tool approval, data classification constraints at hackathon scale that can be 10 lines is a readme, but still count. Some use case are prohibited outright. Regulators advise sensitive personal data, legal constraints you can't meet this week. Otherwise, other are permitted only in approved tool and scope environment. So that's actually the key questions for the Gate Zero. Should AI be used for this task at all? If yes, who owns it and understand what limits? Okay, and once the use is authorized, we define the intended outcome. That's the Gate 1. So poor intent cannot be repaired by pattern prompting alone. A beautiful prompt with a vague goal still produce unverifiable output. If you cannot define what good look like, you cannot verify the AI outcome is good. So get one produce the standard. So you will see on the get four, we test again. On the left column, so let's start with the problem and intended user. Who need and in what context? You should very clear about the user. Next is acceptance criterion. Observable condition for approval, functional and non-functional, required sources, authorities, documents, API data, what count as truth. Prohibits outcomes. This is what must never happen, even if the man test succeeds. That's look like scope as well. And risk tolerance is what uncertainty is acceptable, not token generated, or this is not a line of code. And the last one is a human decision owner. You should know who may accept risk at the approval time. It's very clear when we start, before we start coding with AI. And on the right side, we have a weakness. Let's say we have some kind of not good prompting. For example, just as prompt build a secure login system. So imagine secure is not testable, and the agent will confidently guess. So if we want to make it stronger, it just names the approval identity provider, reserve authorization behavior, no new public endpoint, pass specify security test, reversible changes, and you can actually verify that. Prompt quality help, but requirement need ownership, traceability and testability. A detailed prompt is one input, not validated requirement. So don't over prompting, but be very specific what you need. So that is the get one we have, and after define the outcome, can change the system input and authorities. We move to get to give the AI only what it needs to complete the task, not everything it could reach. Okay, so zero trust AI discipline is not only checking outputs, it is also the constraint for data, context, and tool. So the system cannot create or execute out of scope outcome in the first place. Here is a control before you generate minimum necessary data, only what the task require. Okay, the blast radius, let's say, and approve knowledge sources with repository, document, whatever as truth, and the whole, not the whole entire company document or task. Source lineage and freshness. When did this context come? Is it still current, a valid one? Tool allow less quick action and tool are permitted for this task, especially list privilege, scope access by repository, environment, back access, time, very important. Don't give the, the full power to AI. Environment isolations, that's a feature brand, sandbox, the staging tenant, not the production by default. This is the environment, right? Seric protection. Seric never belongs to inner prompt. It should never have display in prompt, block model context, or untrusted tool. And for context and retention control, design what gets stored before executing. Start. Okay, so the shape that match your work is first thing is engineering agent default. That can be feature brand, repository scope access, no direct production deploy, no secret in the agent context. It places approval for migrations and security control changes. Business agent default restricted recipient transaction limit confirmation before external communication, customer data asset control. So for example, for the hackathon build team, you mostly the engineering default, even your product look like a business app, right? And for an engineering agent, a responsible started point is repository scope access on a feature brand, no production deployment, no direct CRIC access, and a human in the loop for the schema migration or authentication changes. So once constraints generation should occur in a control and inspectable ways. That's the gate tree. So you can see the gate tree control how generation happens. The organization must see what was generated and how it changed the system, not just the chat summaries. So, and we have here 7 requirements. Isolated workspace. Failure here must not directly after production or sensitive system. Version control changes. Something can be attributable, reviewable, and reversible. Reproducible configurations. Records model, prompt, version, workflow, tool, and context reference. Approves model and tool. So stay within that get zero auto-write, right? This is the mention in the get zero. Only use the approve tool. Complete the change difference. Reviewers see the actual proposed change, not only the agent narrative. No silent production actions, no rushing consequential boundaries without a required decision. Define stop condition. Uncertainty, tool error, scope expansions, policy violations, pause and escalate, not try to improve. So you can see the flow here is prompt, plans, draft and brief, and evidence request. Generation is a proposal change, not a black box. A bottom right tree shape of inspectable output here we have for code, branch, diff, commit, dependency, changes, test, and for contain, here we can have review of records, approve version, and for agent action we have plan for sure and propose action. So the best practice here is always trying with a plan first. So we can verify proposal and detailed step that the agents might implement for you. So generation should create an inspectable proposal. You should distinguish what the AI suggested, what the reviewer proposed, approves, and what actually changes. Don't fully count on AI. So that's why we always need the human in the loop. If you have any questions, just stop me. Otherwise, I keep saying I'm talkative. Okay, now verify independently. We move to gate 4. This is the core assurance gate. Everything since the gate 0 built toward this moment. Can you prove the outcome match that what you define in gate 1 using evidence the generator did not grade itself. So independently execute evidence. Verification must be independent of the generating model and tied to acceptance criteria. The exact evidence depends on risk tier and use case. But the pattern is always get one, define the bar, get four, produce proof. So let's look at the type of evidence you can combine. So the first one is unit test, unit iteration and end-to-end test, not only unit test. That's a functional behavior under expected condition, integration catch what the test miss, security scanning, and dependency review. That's a questions Sigma team just raised, right? And we actually should have multi-agent. Each will take one responsibilities. At Mentomy, we also have an agent, and the project agent soon will be become a security scanner as well. So to check a secret and on any supply chain. And BROM injection testing, that is not only the happy path input. You can try, you should try to test any potential risk by the injection. That's also mentioned by Peter before. Source and validations. That's for contains were a source name and does it support the claim? Ground truth comparisons. We have the current reference data, bias, cultural and impact evaluations, who is affected. Independent model or human evaluation, someone or something other than the generator. And the last one, the runtime simulations, that's about a great limit, tool failure, rollbacks, and degraded dependencies. And so you see the red box, that's a do not accept, right? Code look correct, model say it check. Demo work, respond in lost citation. So that is a red box, should not accept it. So, and verification is claim specific. Compilations prove a narrow properties. A citation prove a source was named, not the answers is true. A scan prove what is true cover. Your evidence set must collectively address the actual acceptance criteria and also the material failure mode. So for the hackathon, you can think about to have maybe the agents run the test, scan for any security risk. That's also the good point. Any questions so far? Hope you're going good. Get fine, approve accountability. So approval is acceptance of residual risk, not the causal click, right? It's produce evidence. Get form produce evidence. Get fine is where human, not the AI, design. Given what we know is the remaining uncertainties for this scope, approvals do not mean providing zero risk. It means a qualified authority review evidence, and constantly accepted the remaining uncertainty. That's where the approval happened. The approver does not have to rerun every test, but must understand the evidence and the risk. On the left-hand side, we have 7 requirements. A qualified reviewer who understands the domain can interpret the evidence. Appropriate authorities, decision rights, reportation to consequence. Not every owner can approve every risk. Evidence visibility, who see actual artifact, failure, limitation, exception, not just only the agent summary. Conflicts separations, avoid sole self-approval by the generator. If who the one who made the code, you shouldn't approve this code. It places decision. That's the record approve, reject, or approve with condition, or any escalation. Expiration where appropriate. Reapproval after something changes. Material requirement change. Model update or time limit. High-risk decision may need dual approval or designated authorities, security, privacy, legal, identity, regulators, or high-impact concern. Sorry. Okay. So a product or feature owner does not automatically approve every AI output. Specialized approval may be required for those domains. For example, working as a team, maybe we should have senior or expert guy get involved into the approval process if this is about a technical decision, technical implementation as well. So remember, the most senior people is not always the best approval. You need authorities and relevant competence. Dual approvals sometimes may be appropriate. Approval leads to control release, not unlimited exposure. That's the get sick. We have release safely. Deployment should be proportional to uncertainty and consequence. At the get file, it said yes to residual risk, but the get sick control how much exposure you take at once. AI assisted team can shift fast. This gate stop you from going straight to build blast radius. Release control should start with the control deployment, not accidental push to productions. Stay roll out, limit user data scope or workflow before everyone in. Using feature flags. I'm not sure if anyone here have been used the feature flag. That's also very good approach to roll out feature. So we turn capabilities off fast without a full redeployment. Rate and transaction limits cap how quickly and how much harm an error can reage. Canary release. Small slide first compared to the baseline. Some This also called a radial release or kind of A/B test. That's quite the same meaning. Rollback plans restore prior state, reserve data changes, revoke permission. So we sometimes ship feature so fast, but when it have incident on production, we actually don't have a plan to roll it back. So that's why the team should always have a plan, so to prepare for the worst situation. Communication plan, who you tell when something go wrong. Teammates, PM, organizer, we should have a contact point. Incident owner, who can stop the system and coordinate response. So the deployment progressions we have here is shadow mode, internal pilots, limited cohorts, stage autonomy, and finally broad release. For agentic system, shadow mode and read only are powerful. Observe behavior before granting action authorities. And important points is when rollback is hard, what should we do? I also have some fall into some case where we couldn't roll back the previous changes. So it's a time the release threshold must raise. The less reversible the outcome, the stronger the evidence and approval need before release. When rollbacks is possible, design is a part of the control system, not an afterthought. After we ship the new feature to production, this is not the end, right? This is just the starting point of the monitor, and we learn close the loop. That is where the get 7 and 8 take place. Production behavior must continuously update the assurance system. Production is where assumption meet reality. Deployment is not the end of evidence. It is the beginning of observed evidence. AI assurance does not stop at release. So what to monitor? Quality and accuracy. Does the output still match your get one acceptance criteria? That's a very important point. Security signal from tool code data access, permission use, graph model data behavior grifting from your evaluation baseline, cost and latency, burning token, slow performance, or any surprising cost uh, during the productions. User impact. This is about wrong result, right? And we try to make we try to deliver the feature, but it's not really the correct one. It's not fulfill the user expectation. Override frequency. Humans constantly correcting the AI means the control system is failing. And agent action. What did the agent actually do? Not what the just summary claim, right? We I have been using AI, and the more important point here is the instruction and guardrail we set for the AI. Sometimes you can may heard about the context engineering, and that is how we build the context. We give the instruction for the AI to control the action from AI. Policy exceptions, unresolved risk acceptance. This is just this one path. An incident, when we got incident, is actually we couldn't deliver the good qualities, and it's already happened. And what to do when the signal fail? Preserve relevant evidence. So we need to double check log. We look back the prompt, and we check the output as well before you release or you try with any hotfix. Identify control failure, which assumption was wrong, and which gate should have got this. Update evaluations, can add a test fix that can catch this. We update the prompts, tool, and policy to tighten constraints, revoke permission, or fix any promptings. Raise a risk tier. This is if scale, data, populations, or consequence changes, tier 2 may no longer fit. That we can take consideration to adjust the level of tier. Communicate lessons. That's the time we should sit together as a team, and we can do some root cause analysis and learn from it to have the better monitoring in the future. We don't fall into the same situations. So every incident should improve the control system. Failure become new tests, control, drums, training, and policies. If you don't have any questions, so I move on to the module 5. Module 4 gave us the 9 gate, and module 5 is how that becomes something you can run, not something you remember from the slide. Evidence, role, metrics, maturities, convert gate into records, reproducibility, measurement, and a realistic maturity path. A discipline cannot run a good intention or slogan. It needs evidence records, role metric, and the target. That's a system you can audit, improve, and own. The evidence change. Every consequential AI outcome should be reconstructible. So this map to get you already learned intents. Why the work existed? Who need it? What's the set mean? That's a get one. Context, which model, data, instruction, tool, permission influence the work. Get two. Generations, what were proposed or produced, and how it differ from before. That's a get three. and verifications with test review actually ran with result scope, environment failure, and limit. Approval who accept the risk, under what condition, for what scope. Get 5. Release how exposure were can change, monitor and make reversible. That's get 6. And finally, the outcome. The outcome is what actually happened. Maybe it's an error, override, user impact, and learning. That get 7 and 8. So you can see the broken chains create unanswerable questions during the incident, audit, and executive review. Imagines an investigation 6 months later. Can you explain which model or context produced the change? What evidence justified release? Who approved the exception? Or whether production behave differently from testing? So that's it. Are you guys still okay? Yeah, we almost done it.
Yeah, give some signal to motivate the speaker. Yeah, give him some heart, some applause. Yeah.
I can go quickly, so stay calm. All right, so and minimum AI assurance records. What is it? So this is just the auditable map of the AI outcome. It can be the ticket template, chain form, highlight artifacts, or any evidence bundle. This is you can see what the minimum record contains, intended outcome, and accountable owner. This is the business purpose and who answer if it break. Get 0 and get 1, we just mentioned before. Risk tier and acceptance criteria. Tier 2 for most hackathon MVP, testable success condition, model ROM workflow and tool identity, which model, which prompt version, maybe cursor, lovable, class, and this is with range. Get 2, data and knowledge sources, classification, approved feature, provenance. Don't just copy, never copy the sensitive content into the new document. Generated artifact action and chain records. Let's try to document everything, not only the agent summary. We should check the different transaction or the output. Verification, evidence, finding, and exception. That's the executive test, environment scope, failure reviewer, unresolved limits with the owner and expiry. And the final one, approval, release, rollback, monitoring, and lesson learned. Who accepted risk? How exposure were stay, rollback, owner, what you can observe, what change after. Okay, so accountability model. AI cannot own risk, right? The human does. So the AI cannot never to be the accountable owner. It cannot accept legal or any business responsibilities or prove a policy exception answer for the incident. So every decision need a human or organizational authorities. So here we have a role, each are a different part of the assurance system. Okay, I can move quickly. I believe this is quite similar for everyone. We have business owner, AI system owner. Someone may curious AI system owner. This is when the model is supplied as a service. Someone on your team still own how it used. That's the vendor, the not own your workflow. So an important point here is shared responsibility does not mean equal responsibility or everyone owe it. Responsibility are distributed, but each decision and control need a name owner. If everyone is responsible, no one is. That's the main point. Okay, and this slide is about the control must be proportional to risk. Over control cause bypass, under control cause preventable incidents. Same control level should not apply to ransomware or production identity changes. Risk-based government is sustainable government. That's the magic. So the measure speed and control together, AI productivity magic alone are incomplete. Velocity without control, high rework and risk. So as you see in the slide, metrics change behavior. A target of 100% AI adoption can encourage inappropriate use. A target of 100% test pass can encourage weak tests or hidden failure. So pair every speed measure with an outcome or just add cap risk measurement. So, someone may misunderstanding about a high evaluation pass rate proves trustworthiness, but actually the test can be incomplete, stale, biased, or disconnected from production. So that's why the Gate 4 is about executed evidence, not just the written patch. So this is the last slide of the module 5. Here we talk about a maturity model. Aim for maturity that fit business consequence and adoption pace. Do not jump from unmanaged to adaptive automation because one agent has a fancy policy engine. Maturity is an organizational capability, demonstrates consistently across a defined scope, not just a one-time tool purchase. And here we can see this 6 level from the left to right. And so just want to share one more point is So maturity is not a technology purchase. That's ownership, policy competence in sensitive evidence, process architecture, monitoring and learning. That's the all the gate we just mentioned before. All right, I think I have just done my part. I'm not sure if we have time, but I think the last part is for Peter for the practical exercise. Should we continue or we skip it?
Yeah, I think like we run a bit out of time, and yeah, so I think like it should be done by here. Is it okay? Thank you a lot, David and Peter, for the very like deep training today, and I think it's very useful for all the participants. To change the environment a little bit, so I think like we should take a picture together. Because like we haven't take picture with each other in this afternoon session, so may you all turn on the camera so we can capture the moment with speaker David and Peter. And they are still wake up like Mr. And Peter, he's still very awake. So we should take this a moment to capture the energy, right? Okay, so please turn on the
1 second.
camera.
One
Yeah,
minute.
do a little
Lucy,
bit
1 minute.
different.
I wanted to show the group one last slide. It's kind of important for them to be taken away at the end of the course. Just one slide. So if you can go back to the presentation, please.
Okay, yeah. So one more slide, one more bonus before the
I
picture.
promise, just one slide. The rest of it is the practical stuff. We can skip that. So Lynn, can you present the screen again, please? Okay, go back. One more. One. There, stop. Okay, so this slide is important. It's a good takeaway for you guys, right? So in the beginning, we talked about the 30, 60, 90 days implementation path. Take this back to your organization, or, you know, even if you're working in college in your project, take this to heart. Okay, so the first 30 days, take inventory, use, assign owners, define risks, tiers, select and pivot workflow. Day 31 to 60 at evidence gates, approval, authority, permission, limits, and exception process. Days 61 to 90, measure gate, compliance, expand more workflow. I can't see, I'm sorry, it's getting late. Retest drift and report to leadership. So then after that, what you need to do is pick a consequential tier 2 workflow first. What does that mean? That means that pick an important one. Okay. Pick a workflow that belongs to tier 2. Do not attempt to grant enterprise rollout. Just test. Okay. Test the pattern to see how it works for you. And then use your current organization's SDLC process, software development. I forgot what LC is for. GRC, government risk compliance, ticketing, CI/CD, and monitoring system where possible. Do this exercise. Please do this exercise. Even if you don't implement the actual code, do the exercise mentally. It will help you understand the entire process. Okay, so what I'm telling you guys today is this training, the Zero Trust AI engineering discipline, does not exist in the industry today. This is new. Okay, so we are presenting something that is very new to the industry to try to bring everybody back into sanity when it comes to AI application and production. Okay, so then with that, let's go ahead and I'm done. Let's go ahead and take a picture. I would drop in the repository for Project Aegis so you can use it. Look at the README file. And then I'll also drop in my LinkedIn as well. So if you have any questions, feel free to reach out. And that is all. Thank you so much for attending. We are looking forward to see you in the actual hackathon. Go kill it.
Yeah, that's wonderful. Thank you, and Peter. So he gave all of his heart in the training. Yeah. So we go back to turn on the camera. Please stop sharing, and we take the picture together before we move to the next part. Okay, are you ready to take over of this picture taking?
I'm ready.
Yeah. So please turn on your camera. The remaining participant. Okay. Yeah. You please lead this one.
Okay. I will count to 3. So 1, 2, 3. Okay, thank you everyone.
Nice. Thanks a lot. And yeah, thank you to the wonderful training. And we hope that like 3 of our training give you like the information. It is your benefit to with the hackathon, and all of that is you can use beside the hackathon, you can use in the future as well. So now turn to the important one. We review the challenges and welcome back our academic manager, Mr. Oliver. So who will review the business challenge? So over to you, Oliver.
Thank you so much, team, for such an amazing training. So I hope that you still have some energies for our topic and challenge review sections. How are you guys feeling now? Are you guys excited? Are you guys worried, tired, out of energy, or still have some energy for us? Cool. I see a lot of lights, hearts. So yeah, won't take more time from anyone. Let's discover with me what is your challenge for the Mentor Me Futura Remix Hackathon this year. Okay, can I move to the next slide, please? Just one more before we go back to this one. Just the next slide, if you can. Cool. So let me walk you through the problem that we want to solve together in this hackathon. So, as you know, that Australia is one of the most attractive destinations for many international students and global talents from different countries in the world, including Vietnam. So we know that we have more than 680,000 international students in Australia just from January to May 2026. And that number is actually increasing 2% compared to the same period last year. At the same time, 69% of Australian employers report that it is really hard for them to find skilled talent here in the country. A lot of the employers believe that AI capability will become an essential workforce skill within the next 5 years. So the real challenge here for the countries and for global talent is that Australia is not lacking talent. We do have a lot of talents here, but still at the same time, there's a gap between people who want the job and then the employers who want people. So for this hackathon, we are going to solve this problem together because Mentor Me, we believe that because talent is here, we should help them bridge the gap between what the employers need and what they need to do. So if we can go to the next slide. Can I just get everyone, my admin, to go to the next slide? Perfect. So the challenge questions that we want all of the teams to answer is, how might we use AI, data, and digital technology to help international students and skilled migrants access meaningful career opportunities in the country? while helping Australian employers identify, develop, and retain diverse talent. Well, I guess this is a very broad challenge. You do not need to solve the entire international student employment problem. Instead, what we really want you to do is identify one specific problem, one clear target user, and one solutions that create genuine values. For example, you could work on career navigation, helping someone understand what career paths are available for them and what they can do to meet that career expectation. You can also look at skills recognitions and job matching, particularly how international experience can be translated into Australian employment context. Or you can focus on employability and career readiness, such as applications, interviews, network, or understanding employer expectation tool. Or you can solve the problem from the employer sides as well, such as recruitment, workforce planning, or talent retentions. So all of those can be your solutions. So I think my advice for everyone is do not start by saying, I want to build an AI chatbot. Start with the problem. Ask, who am I helping? What is the difficult for them today? Why does that problem matter? And how can technology or AI genuinely improve that experience? If we can go to the next slides. Perfect. So we do provide a little bit of challenge guidelines for everyone. Again, I just want to make sure that your team does not need to solve every part of the challenge. You should identify only one clear problem and then one main target user and the realistic solutions that can be developed within the scope of our hackathon. I guess the strong submission should have a clear, defined user problem and evidence that the problem matters, and a focus on solutions that could realistically be implemented within your time. We actually want to see something working. That could be an AI agent, that could be a website, that could be a mobile application, that could be a dashboard or a recommendation system, automation tool, or another digital product that you can bring to us. It does not need to be production ready. So when I say it does not need to be production ready, we don't want you to build something that can go to the market tomorrow because it is impossible within 2 days, right? But by the end of the hackathon, we should be able to understand how your solution works and why it creates values for your target audience. AI is definitely encouraged, but using AI does not make a solution better in the sense. So you can use AI to build your solutions, but your solutions does not need to be AI native or AI focused, if that makes sense. Well, I guess some more notes for everyone that if you are working with employment or personal information, make sure to consider privacy, bias, fairness, transparency, and also human oversight, right? I think that's pretty much what we want to explain to you about the challenge. On behalf of MentorMe and all of the trainers, mentors, and churches, I guess I would love to say a best wish for everyone. Good luck. And I am very excited to see what you can build. I know that the challenge is big, but I would be keen to see what you can build from here. I am open for any questions if you have. So if you do have any questions, have something to clarify, want to check with me if you understand the challenges correctly, feel free to let me know. Yeah, so give it back your time. And I think our team would also send you the questions and challenge brief after the section today as well. So you would be able to read the question again if you need. But yeah, I'll be here to answer any question if you have. So let me know.
Okay, so time to ask question. Clarity you may need. Okay, there is one open. Please turn on the mic and ask. your question?
Hi, Oliver. So I'm wondering, because I think I touched the last part. You mentioned that it doesn't have to be market tomorrow. So because usually for my experience, sometimes I made a system or a model. It works on my computer, but when I started on the second time, or when my partner started on his or her computer, something went wrong. So is that okay for tomorrow's, or like as long as it could be work on my computer, I could make a video out of it, and then it should be good, or
Yeah, I think that's totally fine. We don't expect you to deploy your solutions on the cloud and share with everyone tomorrow, right? So definitely something work on your local machine would be enough. But I think the more important point here is, okay, with your problem that you identified, with that solution, it's actually solving the problem. I think that will be something that we care more about. Definitely, we don't want like a production level solutions. So that's okay that it can only solve part of the problem. It's okay that you can only demonstrate for one specific use case. I think that's totally fine because we understand that you only have a day and a half. So yeah, don't stress at all because I think that's the whole point of hackathon, right? So we're trying to demonstrate the idea and then try and see if you can identify the right problems and use your critical thinking and AI to be able to demonstrate your thought process. So totally fine. Good luck.
Okay, any more questions?
I'm sorry, I have a question.
Yes.
So, according to the slides yesterday, our deadline is at 11:30 a.m. Vietnam time. So, the rest of the time from 11:30 to 3 p.m., what is it before?
Sorry, can Lynn go to the agenda again for day 3? Wait a minute. There is a slide on the agenda for 3 days. Okay, I don't get it here. So after the submission, there will be Thiện have the we will have no, we have the slide on the 3-day agenda I remember on the slide of day 1 yesterday. We can open it again so we can explain to the team.
Well, I guess the simple answer would be, well, definitely we want you to submit by 11:30, and that's definitely like a bit of the gap between the submission deadline and then when you need to present the solution. We do need a bit of time for all of the judges to go through the solutions before actually judging your presentations. So if that answers your questions.
I see.
Yeah.
Right.
Cool. Do we have any other questions or clarifications that you need from myself on the challenge that we just released?
Hi.
Oh, sorry, go ahead first.
Oh, you can go ahead first if you want.
Okay. Yeah, lady first, I guess.
Yeah.
Thank you. So maybe a silly one. Because according to yesterday's slide, we need to submit like a PDF version of pitch deck. So what if I want the things I want to do is like a website? Then how do I fit in PDF? Like, is it like format for us? Like maybe for the pitch deck, we want like introductions and everything functionality and then etc.
Well, I guess if you have like a website, I think the demo video would definitely be somewhere that you can showcase your website, right? And in the PDF, like the pitch, the slides, if you want to take some screenshot there, I think that would be very welcome to do that. And then I think in your presentation, it will be to decide what you want to show, right? So you can show your website if you want to. I think that will be more on how you want to present it to the judges. And
Okay.
yeah, I think if you want to like take the screenshot of your website and send it to it, that's fine. So as long as we can understand your problem and your solutions, I think it would be okay.
Okay. Thank you, Oliver.
No worries.
Okay,
Didn't mean to
one more question, right?
Yeah, I was gonna ask, like, we're allowed to build and work on this outside of the time that we're not on the call, right? We can just like, if the call ends, we can just like work together in the downtime instead of like joining it from 8 a.m. to like um 11:20 to work on it.
Yeah, of course, you can work on
Okay.
it tonight if you want to. So you're very welcome to work on your solutions anytime from now.
Gotcha. Thank you.
Yeah. Yeah, and you don't have to go into Zoom, so there's no invigilated Zoom for everyone. So feel free to just build it on your own time.
Okay, I just passed the agenda for 3 days again in the chat box. And so after the submission, you will have like 30 minutes for preparation, and we will start the pitching time and judging from 12:10 p.m. Vietnam time. So you just read it and for your preparation. Any more questions to Oliver for the business challenge? Okay. If no, like, this is the reminder of the submission and final deliverables. So pitch deck will be in PDF format, and the GitHub repository will be in the public link. And remember to have the 3 minutes demo video in the YouTube link to submit to us as well. And the file naming order. So you remember your team name first and then the project name. So it is easy for us to identify which team is submitted. So we will need one representative from your team to submit, not all 3 of you. So one only to submit to us for the final one. And please screenshot. This one is the submission channel on the email, the CC to Linh Nguyễn, and the subject is Futura Remix 2026 with your team name and the word submission. This is like the hard cut-off day. Okay, and next I will remind you again on the scoring. Next slide, please. Yeah, so 20% of your score is the commitment that you have been through with us day 1, day 2, and day 3 tomorrow. So you remember to stay after this session to do the feedback. It's count for your score. And the rest 80% will be like in the so will be like day 1, day 2 commitment, the problem and user understanding is 12%. All of this one, so you can screenshot, and our team will email you the judging criteria again to your email with the business issue already. So please reach out if you have any questions. And yeah, I think it will conclude today's session. So please turn on next slide for everyone to do the QR code for the feedback. So please do it. I think this is a long day today, so just do it quickly and then you can rest. And we'll be back tomorrow at 8 a.m. Vietnam time to start the day 3. So take a rest and to have a lot of energy for the due date tomorrow. Okay, so any team finish the feedback, please type 3 in the chat box so we can follow for you. May have some music to wake them up. This is the end of the day. Yeah.
Green cross glowing down the street. Cool night underneath my feet. Traffic fading block by block. 1:30 on every clock. Didn't need to buy a thing, still I stopped beneath the green. Something in the steady light made the silence feel alright. Quiet pharmacy sign tonight, floating in the humid air. Little glow against the darkness, waiting there.
Thank you. Bảo Ngọc VN and Sigma. Okay.
Sliding softly down the glass. I don't need to rush the healing. Some things fade away with time.
Okay, thank you, Min. Yeah.
Plastic umbrella dripping rain.
So any team finish, I think you can continue now. Thank you a lot again for attending today and wish you good luck for the competition and we'll see you tomorrow, 8 a.m. in time.
Still I stop beneath the green. Something in
Yeah, please send the heart to like on the speaker, the trainer today. So it was really hard for the training.
tonight, keeping company with me. Every tiny electric hum.
The other team, the remaining team, please try free when you finish.
Every lonely thought behind me, softening without a sound. I don't need to name the reason why this calm is
Accelerated nerve,
no big cure, nothing.
AI Riser, have you done?
Just the night and shades of blue.
Thank you.
Light above the road.
We will close this link in the next like 9 minutes.
Quiet pharmacy sign tonight. Yeah, small green star against.
Thank you, Antonio. Good night to you. Thanks a lot.
Through the dark
Thank you. Accelerate.
till I
See you all. Goodbye.
again.
Good night. Thank you. Bye-bye.
Bye bye. Andrea. Thank you. Accelerate. Thank you. We've done for today. Good luck to you all tomorrow.
Plastic bench beneath.
Okay.